Okay, so we left off where you guys were going to start graphing this. So for 3 pi over 4, 3/4, what do we get for that value?
0.7.
Yeah,
0.7, so it should be about the same height. At 0, sine is 0. At pi, sine is
0.
At 2 pi,
0.
Also 0.
at 3/2,
1.
Negative.
it's down here at -1.
Negative.
Anthony, negative pi over 2, what do you got?
-1.
-1, that looks, sounds good. Negative pi,
0.
-2 pi,
0.
and -3/2 pi.
1.
So now if we connect all those points, we should have that. Ooh, that doesn't look good.
Well,
Should look like that. Okay, so there's the sine function. Is it periodic? Yeah, it's definitely periodic. Now notice, I gave you a specific number of values. I could have also given you like pi over 8, something in there, and you'd be able to see that it creates a smooth, nice, smooth curve a little better, but I didn't figure you'd need that to figure it out. Okay? Makes sense, right?
So the period is 2 pi.
Ah, Jake is telling me the period. He said it's 2 pi. You guys agree? You got to think about where a cycle starts and ends. So you could either say it starts here and ends there. How long is that? 2 pi. If you say it starts here, where's the cycle end?
Pi.
It goes like this until you get there. How long is that again? 2 pi. So does it really matter like where you start? The period's still 2 pi. We're also going to introduce this other idea called amplitude. It's very easy to work with trig functions, amplitude.
How higher, like, the
Yeah.
lower it goes.
How high or low were you guys learning that at?
I learned it in
Science.
conceptual physics.
In science?
It's
Okay. So what's the amplitude of this function then? 1. So you don't count the whole, there's the width of the corridor. How wide is the corridor? 2, but the amplitude is how high up or down, and that's 1. Good. Amplitude can always has to be positive. So even if you've got like a negative function we'll be working with, you still consider the amplitude
Well, it's a
as
distance.
it's a distance. Excellent. So it's got to be positive. It's a distance. Great. Okay. So there's the sine function. Cosine function I'll leave to you guys. Once you plot it, you should notice there's only going to be one difference between it and the sine function.
It's just moved over a little
It
bit.
kind of looks like it's been flipped or moved over. So the sine function, they're easy to remember how to graph them. You remember to start drawing the sine function, where do you start?
Pi over 2. Or net, or yeah.
Always start on the y-axis. So where do you start?
0.
At the origin, you go out to 2 pi and you draw a thing like that. And then you just continue it backwards.
So for cosine, you
Does it stop right here?
No.
Why does it keep going?
Coterminal.
You can keep adding.
You can keep adding or subtracting angles at coterminal. Very good. So what should I really put on the ends?
Errors.
I should put arrows because that cycle is going to just continue to repeat. Okay? So sine, you start by drawing at the origin and you draw its cycle. Cosine, anybody tell me where cosine starts? Where do you start it?
Pi over
Oh yeah.
0, 1.
Instead of at 0, you started at
0.
up there at 1, and it should be similar looking. Okay? So tell me what the period, the amplitude of cosine are in that sheet, and that's all you need to do by tomorrow. You guys should be able to get it done in class, I think. So. All right. So we will look at how to transform these functions tomorrow, which is very easy, easier than normal functions. Weighted transformations with other functions, I think sometimes it's a little tricky sometimes. Trig functions, easiest ones to transform.